gave us 3 math problems that we just had to do. And we had class too.
Well, that's
Like the
good.
last like 15 minutes of the class.
It's unusual.
I know. It feels so weird. Is it
We're broke on Friday.
nice to change?
No. Hopefully this one will stay throughout the 049. I gotta go. Hopefully Miss Rice is ready because we have to hang up measuring tapes and line.
Oh, is it too?
Thanks. Xavier made it.
I don't know better. Yeah.
This that kid is always in Coach C's room, with the curly hair, talks a lot. You'd know him if you saw him. You'd be like, oh, that kid.
There's these people in my access that talk a lot, and when they're not here, it's so quiet and peaceful. Oh my God, there's this one kid.
Boring. Okay. Oh, okay. What base is number one going to be? What's the common base in this one? 5. Okay. So over here, oh no. 125 is 5 to the third. 25 is 5 squared. 5 to the third. And then the b minus 2 gets multiplied onto the 3. 5 squared. The 2b gets multiplied onto the 2. Cancel, cancel. 3b minus 6 equals 4b. Distribute. Do you want me to put the little rainbow there?
No, no, I was confused, but you went from 5 to 4. But not,
Oh, this part, I just did 2 times 2b.
yeah.
No, no, it's early. Okay, so there's number 1. And number 2, we're going to put equals x. And then Guinan circle. How it's multitasking. Okay. 5 to the x equals 25. Does this make sense? The log to exponential form? We got that? Okay. And then we can use our tree from up here. 5 to the x equals 5 squared. Cancel, cancel, x equals 2. I missed you. Are you better? Okay, everybody, any questions on the 2 warm-ups? These were kind of easy ones, but that's okay. Nothing wrong with easy ones on a Monday morning, right? Okay. Let me show you the agenda for today. So today we're going to, okay, so first thing we're going to do is review some stuff from logs. And the reason is because the book thinks that we did chapter 6. So we didn't do chapter six. Chapter six is all statistics. So they're taking the first few problems to remind you about logs, even though you guys just did logs. So they're thinking it's been like 3 weeks since you've done logs. But it's good to review it anyway. So we're still gonna review it. Then we're going to start to work on the properties of logs. Logs have their own properties, which is not a huge deal, but we're gonna work on that all week. By the way, on Friday, we have I think it's Friday. Yes, we have a little play we're gonna do in class. I'm gonna need a few people who are not shy to read a few parts aloud. Connor's gonna be one of them for sure. And it's like not a big deal, and you don't have to get up in front of the class or anything. You can read it from your desk, and we'll highlight the parts beforehand. It's just like a math problem, little play. But look forward to it. It's gonna be fun. So just, if you're interested in reading a part, Connor, you have no choice. You have to do it. But let me know and we'll figure that out. Okay, anyway, homework tonight is 7, 11, 12, and 13. And yeah. Do you understand my joke? Yeah, so let's log with rhythm. Log with rhythm there. Yeah, I'm really getting to the bottom of the barrel of logarithm jokes, guys. But it's good. Okay, so here is your setup. Theo, do you want to see my warm-up? Hey guys, so who are we still missing besides Theo? Who? Maybe. Question. Theo, Vivi, question. Okay. Jack, I think you'll probably get all of those
Oh,
Did you get my thing for Wednesday? No, access appointment. I'll excuse you from the scavenger. Okay, everybody. So this is just old stuff. This A was really no math. There's just reminding you about the Guinan circle. And over here, notice the Y is on the other side, and it's okay to do your Guinan circle that way. So this is what you need to remember. The Guinan circle always goes around the equals. So if the equals is on the other side, it's okay. So notice this would be b to the y equals x, which is b to the y equals x over here. So Guinan circle can go to the left, it can go to the right. You just need to make sure it goes around the equals. Okay, the last thing we did in chapter 5 was we talked about the difference between these two things. And this is plain log. So we're just going to write a little bit about plain log. Log of x is log base 10. So whenever you see a plain log, you can put a little baby base 10 in there. That helps you. And when you have plain log, you can push the log button on the calculator, which is right next to the 7. So right here is 7, and the log button is right next to that. And this log, this plain log, is log base 10. That was the very, very last thing we learned in chapter 5. Sit across from Jack, okay, right there. Thank you. Okay, now we also learned about log base everything else. And in the calculator, you go to math and then scroll to log base. So if you guys could all, after you write that, just take a second, please, and make sure that you find the log button and the log base on the calculator. Yes, honey. Yeah, please. Yes, please. Now, if you do not have log base on your calculator, please let me know and I will help you graph. You don't have it? Okay. So this is what you're going to do. Okay, so anybody else not have log base on their calculator? So it's okay. So if you go to y equals, first of all, let me get rid of all this. Log x is this. Okay, for the rest of us, if we want to use the base, we go to math and then scroll to log base and you could put 10 like that. These two are the same exact graph, by the way. Okay, so now for Jack, so if you don't have log base, what you're going to do is log, regular log of whatever is in the parentheses divided by log of the base. All three of these things are equivalent to each other. Yes, Eddie?
I think you just said it, but I wasn't like paying attention. How do you get 10? That's log rate, right?
Anyway, so notice, I don't know if you guys saw it, but let me do it again. No, not going to do it again, but it actually graphed 3 times over that same one. So Jack, if I were you, what I would do is I would leave this bit in the calculator at all times. And then I would change the X to be whatever's in parentheses, and I would change this to be whatever's in the base. Just leave that in your calculator so you don't have to think about it. And then what you can do is you can scroll over here to where these equals are, and you can turn it off and turn it on. So you can always leave it there. Does that make sense?
Yeah.
Okay. All right. So now for C, we're going to just put a little bit of the facts from our blue sheets. So the first thing that we learned about log graphs was that they have a vertical asymptote. So just sketch that in. And the vertical asymptote is at x equals h. There's your general form. And that's just a couple of pieces off of the blue sheets. That's the stuff that I care about. And then we just need to sketch it. Remember that it goes forever down no matter what your graphing calculator says. You need to make sure that it goes forever down. Yeah, honey. What? Over here? Nothing. Excellent question. So you got to think about it like an exponent, like a sleeping exponential. So this is like an exponential, sleeping exponential. So that's basically a little summary of the blue sheets piece of the logarithm. Any questions about any of that stuff? This is all review. Again, if you guys came in late, the reason the book is reviewing this right now is because they think we did chapter 6. And we skipped chapter 6 because it's all statistics. So they're reminding you of how to do logs, even though we just did it. So, but it's always good to do. Never a bad thing to review, right? Okay. Any questions so far? All right. Okay, so go ahead and set up number 2. And this looks a little weird. This is a question mark with an equals underneath it. So put your cards in a pile so you know to plug up them up. The next couple of problems, number 2 and 3, we're going to try to discover some properties of logarithms. There's just one that we're working on today. So what we're going to do is first, we're going to put both of those two things in our graphing calculator and see if they make the same graph. So it's perfect time to practice. I'm going to go into my calculator here. I'm going to clear all this stuff out. Okay, and so I'm going to go to this one, log base 2 of x, math button. Scroll down to log base. Two of x. And then this one is plain log. So you just hit the regular log button that's next to the 7 to the x. And then when you're ready, hit the graph button and see if they're the same graph. They're definitely not the same graph. So this one, you got a log, you expect that. Can anyone give me an intelligent reason why we got a line for this? Yes, Jacob?
Log undoes an exponential.
Yep, the log undoes the exponential, so then you just get a linear. Okay, so what we're gonna do is we're gonna sketch this in for A. It doesn't have to be perfect. We're not gonna do tables or anything. So we're just gonna go, okay, this looks like that. And this looks like, it doesn't have to be colored, doesn't have to be colored. Don't worry about it. Okay, and we're gonna come up here into this equals, and we're gonna make that not equal. They're not equal because it didn't make exactly the same graph. Yes, honey?
So is this like one of the problems where like you have to find like equal to,
We're just trying to figure out if different stuff is equal. Okay, and now over here for B, we're gonna show that it's not equal algebraically. Yes, honey?
what would you say if they were equal? If you cross out the question mark?
Yeah. Okay, so, and we're gonna do that in a second. Okay, so we're gonna do both of these. We're gonna make them into exponential and show that they're not equal. But I don't know about you. I like to do my guidance circle to the right. So I'm gonna make the y's on the other side. So I'm gonna call this log base 2 of x equals y. That's the same thing, right? I just moved the y to the other side. Okay, same thing. I just moved my y to the other side. Okay, so now if I do the guidance circle for this one, I have 2 to the y equals x. And what's the base on a regular log? 10. So I'm going to put the little 10 in there. 10 to the y equals 2 to the x. Are those two things the same thing? No. And that just shows graphically that they're not the same thing and algebraically that they're not the same thing. So these two things are not the same thing. That's all we're saying. we're going to put the left side in L1, Y1, the right side in Y2, and see if we get exactly the same graphs, and see if they're equal. You don't have to do anything algebraically. This is all graphing calculator. Does that make sense? You figure out which ones of these are true and which ones are false. And you can definitely talk to each other, help each other enter stuff in the calculator. No, so that one's a no.
They like have to be like.
They have to be identical. Ooh, that one's cool. I don't even know. I really like the graph of the second one, by the way. Cool. Okay, so do you guys all get no for the first one? That's no, but it's cool. Here's the third one. Does the third one work? Yes. Anybody need help with the third one? And what about the fourth one? That one's a no. Okay, this one is very special. It has a name. It's called the power property of logarithms. And why is it special? Well, it's special because you can actually take an exponent that you don't know and move it in the front and make it multiplication. If you think about it, when you multiply, when you take an exponent to a power, it's multiplication. So that's what you should be thinking about here. And what it does is it helps you be able to solve for x, because it's harder to solve for x when x is in the exponent. So if we use the power property, we can get it out of the exponent. Okay, so for number 4, we're going to just write about what that is. Okay, so now we're going to use the power property of logarithm. So this is the first time ever that you will have been able to solve for an exponent when you can't get the same base. Normally, I would tell you to figure out what base would be the same to these, that I could cross them out and equal the exponents. But one of them is a really terrible decimal. It'd be really hard for us to find it. So what I want you guys to do is go on your calculator and do 1.04 to the stuff. So guess and check 1.04 to the stuff until you figure out 1.04 to the what is 2. And I want you to get it down to the 10th place. You're just going to have to try stuff. 1.04 to the 1 is 1.04. So that's going to be, it's going to be above that. So try things. 1.04 to the 2, 1.04 to the 3, 1.04 to the 5. See how close you can get to 2. Tenth place. 5.5. You guys getting like 17.7? Okay, so as I said, I'm not gonna make you go any more detailed than that, but 1.04 to the 17.7 is pretty close to 2. It's not exact, but that's okay. So we're going to say x is approximately 17 17.7 with guess and check. Okay, and now we're going to solve the problem properly using the power property of logarithms. So this is another Mr. Guinan thing. It might be my favorite thing of his. He says when your exponent is stuck in the tree, and he actually says squirrel, I think. When your squirrel is stuck in the tree, what do you do to get the squirrel down? You hit it with a log on both sides. Okay, so we're going to hit this problem with a log on both sides. Okay, so your variable is stuck in the tree. How do I get it down? Hit it with a log on both sides. So I hit it with, it just makes me so happy. I hit it with a log on both sides, and now I have this situation right here. I get to take my exponent, move it to the front, and becomes multiplication. Okay, and if I were you, I would just draw that arrow for the first few times that you do it so that you can follow what on earth you did there. Okay, so on the calculator, you need to make sure to close your parentheses. So this is regular log 2 divided by log 1.04. Make sure to end your parentheses for both. And then for log problems, we usually round to the nearest 10,000th, which is 4 decimal places. So 17.6730. Which is pretty close to 17.7, but much more accurate and easier to find without doing tedious guess and check. Okay, so power property of logarithms means that you can take an exponent, move it in the front, and make it multiplication. That way you can use division to get x by itself.